3.4. We're going to be graphing polynomials. And I just got a bunch of things written out here. That's good stuff. To determine whether the degree of a polynomial is even or odd. By looking at the graph, you have to look at the end behaviors. We've been going through end behaviors, so you should have this down pretty good, but this is kind of a refresher. If both ends are going up or both ends are going down, then it's even. If one is going up, one is going down, then it's odd. So you will notice this right here is going to be even. This one here will be odd because one's going up, one's going down. Same here, odd, up and down. Now, to determine whether the leading coefficient is positive or negative, all you need to look at is the right end behavior. Since this one is going up, it's going to be positive. They're both going up, should be obvious it's positive. Okay, but it's a little more confusing with the odd ones because now this one's going down, so it's negative. This one is going up, so it's positive. So I think that's the easiest way to tell that. Okay. Now, to determine whether a polynomial will function from a set of zeros. Okay, so we know our answers, our solutions, our zeros, -1, 2, -3, and 4. Okay, what you do is you change them into binomials. X plus 1 from -1. X minus 2 from a positive 2. -3 gives you an x plus 3, and a 4 gives you x minus 4. Now, normally what you do at this point is you will FOIL these first two, you will FOIL the last two, and then you will multiply that together. That's a crazy long problem. We're not going to bother doing that. Now, if you get two of them, okay, like two zeros. Now, remember, when you have a zero, it's just an x out front. Well, since there are two of them, we go x squared. Since we have two threes, we again write x minus 3 and we raise it to the second power instead of writing out x minus 3, x minus 3. If you have fractions, fraction of 2/3, remember it's going to be the 2 on the right, the 3 on the left, negative sign because you change signs, and then -3/4, it will be a positive sign, and you have 3 here and the 4 there. Alrighty. Now, in order to determine the least possible degree of a function, you need to locate where the graph crosses the x-axis, the number of zeros. Write those zeros as binomials and figure out whether the function is positive or negative. All right, so in this case, we cross at -5, so we give it an x plus 5. We cross at a positive 7, we give it an x minus 7. Now notice it bounces. Whenever it bounces off of the x-axis, there are two zeros at that point, so we have the x plus 1 quantity squared. Now again, okay, and that's what this is talking about. If it bounces, you have two zeros at that location. Now if it hovers, that means there are three zeros at that location. By the way, let's just go back to this one. They're both pointing down, so that's why we got the negative written in front. Okay, here we go here. We've got, I put it positive because we're pointing up. Put it positive right away. We are bouncing off the -2. So we've got an x plus 2 quantity squared. Now this is what I'm talking about hovering. You come up and it just kind of slowly goes through the 4 and then it shoots up after that. That's when you get cubed. So x minus 4 quantity cubed. All right. To find the total number of possible zeros and turning points of a function, you look at the largest exponent. So in this case, our largest exponent is a 3, so that is the total number of possible real zeros. Now it could be less than that. You could have 1 because imaginary numbers come in pairs, but we're not worried about that. So that we will have 3 there, and then turning point's always just 1 less, so a turning point of 2. Okay, here we got positive real zeros. Our highest exponent is a 4, so that's 4 possible real zeros. And possible turning points would be 1 less than that. It's 3. I don't know why people get confused on that, but just 1 less amount of zeros. Now, factoring wise, we're going to do some factoring in this section. We'll make it so it's a little easier here, but let's say we have this one right here. And we got an x cubed. Now, x cubes are kind of hard to factor, but you'll notice we have an x that is common to both, or to all three, and we also have a 5 that's common to all three. So that means we're going to pull out a 5 and an x, and then you would get x squared minus 2x minus 3. We know, oh my word, look at that, brutal. I did this poorly. Okay, it will be 5x, it's x minus 3, but this would be an x plus 1. Slap myself upside the head. All right, now on this one we got x 8x to the fourth minus 40x squared plus 48. People get confused on this, but let's just go ahead. Let's pull out an 8 first of all, and we get an x to the fourth minus 6x squared plus 8. Now we factor it just like we would factor a binomial that has x squared and x. Just so happens what we do is we just put x squareds in front of both. Factors of 8 that add up to 6, 4 and 2, and they're both negative because it's a minus plus. So we get 8 times quantity x squared minus 4 times quantity x squared minus 2. Now x squared minus 2 we cannot factor down, but the x squared minus 4 we can. That's a difference of squares. So we would write it out as x minus 2, x plus 2 with the 8 out front and the x squared minus 2 there. Alrighty, talk to you later. Bye.